Hello, this is the beginning of your erosion and deposition series of notes. This can be found in Google Classroom. You do have access to this PowerPoint, and you also have access to the notes. I handed out the notes physically, but I'm also attaching the notes in Google Classroom for your resource. My expectation is that you do follow along with the notes, that you write the notes as you listen to my lecture, because if you write something down and listen to it, you're more likely to learn it and understand it. So as we get started here on slide number 5, you're looking at 3 different landforms, and all 3 of these landforms were created by erosion. The first landform we have here, the one that looks like green grass, was created by water erosion. The middle one here was created by wind erosion. And then down here on the bottom, this is water erosion on a coastline or a shoreline. So we're going to get into the details of all 3 of these. So our 2 big pieces of information for this unit are erosion and deposition. Erosion is the moving of rock material and sediment from one place to a new location. Deposition is the process by which an eroded material is dropped or deposited by wind or water or something else. So erosion is the picking up and moving of material such as sand, sediment, and soil, rock. Deposition is the process in which that material that has been eroded is then later dropped or deposited or left behind. So on your notes here, you have a Venn diagram. In the Venn diagram, I would like you to basically say the difference between erosion and deposition, and then what similarities they have with each other. So what you could do is pause the video and put your definition of erosion and deposition in the Venn diagram, but then leave a little bit of room for some more information. So here's erosion in more detail. Eroded material in streams specifically may come from a stream's bed and the banks, as well as the material carried into the stream by rainwater runoff. Over time, erosion can cause a stream to widen and deepen. So here's a picture of that erosion by streams. So up here towards the top, close to the top, is where that erosion is happening. It's happening as material is brought in from land, and it's also happening in the stream bed itself. When it gets down to the end of the river, where the river meets the lake or the ocean down here, this is where deposition is occurring. So if you can kind of see how it's cloudy down in here, that's because of the deposition or the depositing of all that eroded material at the end of the river or stream. Deposition, after streams erode, the rock and soil will drop the deposited material, which is known as their load, downstream. So all of that material that is picked up, that is called the stream's load. The little rocks and pebbles and sand and sediment that it's carrying, that's considered the stream's load. And it's going to carry that load downstream. So in the direction it's traveling, downstream like this. Deposition occurs when gravity downward pulled on the sediment is greater than the pushing flow. So we have 2 things happening in the stream. We have a stream pushing this way, down water, and then we have gravity pulling downward. When the force of gravity is greater than the force of the flowing stream, materials will be deposited. A stream deposits materials along its bed, which is the bottom of the stream, along its banks, and at its mouth. And the mouth is the area down here at the end. That's the mouth. So as you looked at erosion and deposition, here are some things that you could have put in your Venn diagram. So erosion, so this is erosion here. Sorry, my pen isn't always super precise. Erosion is the movement of sediments. Streams can widen and deepen, canyons can form, and it can make streams appear to be muddy. Deposition is when sediments are deposited, it builds something called delta in sand dunes. It creates land. So we're going to talk about some of these things. And then what they have in similarity is they both create landforms. They can both change the Earth's surface, and they both are responsible for moving material. So we're going to get into those details as we go forward. So we're going to start with stream erosion. So there's lots of different ways that materials can be eroded. We are looking to start out with stream erosion. So where you're going to put this stream eroding factors is there is a box on your notes. So stream eroding factors, you are going to use this box down here to focus on the stream eroding factors. And what I would put these bullet points here in this box right here. So gradient. Gradient is the steepness or the slope. When it's very steep or there is a large steepness, the water moves fast, and that means there's more erosion. When there's not a very steep area, the water is going to move slow and there is less erosion. So right here is your steep gradient, so that would be more erosion. And down here is your gentle or not very steep, and that is less erosion. And less erosion also means more deposition. More deposition. Stream eroding factors. So things that impact whether or not the stream erodes quickly or slowly. So the next one is load. So I would put the load area. So these bullet points right here, I would put here in the load area of your table. So materials carried by the river is the load. That's what the river is carrying. So down here is a picture of the load. It could be dissolved material, it could be suspended material, or it can be little rocks and pebbles that bump along the bed. Fast-moving water can carry bigger particles. Large particles can then cause faster erosion. Slow-moving rivers move smaller particles or less particles. And so because they are carrying less particles and those particles are smaller, less erosion happens. And then the last one we have is discharge, the amount of water that a stream carries at a given amount of time. Discharge increases when we have large storms or melting snow. So this is just the amount of flowing water in the stream or river. And so if there's more water, that means more discharge. If there's less water, that's less discharge. The more discharge, the more erosion. And you're going to put that over here where it says discharge. So these three pictures show a young stream, which means it is relatively straight and narrow and fast. And we make our way to an old stream, which does not move very fast. It is very wide, and you can see how it curves. Those curves are called meanders. It's a meandering stream. So in between, you have kind of a little bit of slope, a little bit of curve. It's still moving at a pretty decent speed. So this process happens over time, depending on how fast the erosion and deposition rate are. So you have this picture on your notes. It is a graph that talks about the river gradient. So on our y-axis, we have our altitude. That is our height above sea level. And on our x-axis, we have our stream distance. And so what it's basically showing you is the steepness of the stream. So when the line is fairly straight, that means it's not very steep. And when the line is more vertical, that is showing a steeper area. So the river gradient plot shows how quickly the elevation of the river falls along its course. The slope of the line is the river's gradient or steepness. The line has a steep slope at points along the river where the gradient is steep. The line has a nearly level slope where the gradient is shallow. So we're going to answer a few questions here, number 7, 8, and 9. Along this river, at which two altitude ranges are the gradients the steepest? So to look at the altitudes, we're looking here at this section in through here. This is your altitude, 2 of them. So select 2. So this would kind of be the first area. And then the second area would be right here, between 17,500 and 15,500, and from about 15,000 to 14,000. That is what your answer should probably comprise of here for number 7. Number 8, at which altitude ranges would you expect the highest stream bed erosion rates? So based upon what we know about erosion, and the answer would be the same. Because where you have a steep gradient, you also have greater erosion. So your answers for number 7 and 8 would be the same. And then number 9, at which altitude ranges would you expect the slowest stream bed erosion to be? So where not much erosion is happening is where the stream bed is more shallow. So areas where that is occurring would be here